Okay, so to finish up this problem, I was just saying that my stuff in blue, my x to the power simplifies to be an x squared, and I'm taking the limit as n approaches infinity, and if I'm letting n go out toward infinity, is that going to affect x squared in any way whatsoever? And the answer is no. Okay. However, so the limit's not affecting the x squared, so the x squared doesn't need to be inside the limit because they have no effect on each other. Those absolute value bars do affect x, well, not in this particular case because it's x squared, but they should affect the x value because x could be anything. X could be positive or negative. Okay, so I need the absolute value bars on the x squared. Okay, I'm going to rate it sloppy and then I'll bring it back in with something neat. So I have the absolute value of x squared. Okay, and then as far as the n, limit as n goes towards infinity, that is going to affect my n values, and this stuff here that's simplified with my factorials are all my n stuff. So I need the limit on the n stuff, but not the limit on the x stuff. Also because n is going towards infinity, I hope this isn't so confusing, but because n is going towards positive infinity, those absolute value bars have no effect on n because n has to be positive and n is just getting more and more and more and more positive. So the absolute value bars really just are for my x parts, and the limit is really just for the n parts that are left over after I simplify. So I can rewrite this as x squared times the limit as n goes towards infinity. I'm going to make this nice and neat in a second for you, of my 1 over what was left here, 1 over 2n plus 3 times 2n plus 2. Okay, and I will make that look something legible right now. Hang on. Okay, I don't know why I try to write things by hand. But in any case, this is what we said. So the absolute value of x squared should be on the outside. Now, because it's an x squared, we don't really need those absolute value bars. And then the limit, as n approaches infinity, it should just be on the n stuff. And the n stuff don't need absolute value bars because they're all positive and they're just getting more and more positive because n is approaching positive infinity. Now, if you look at this part, okay, if I take this limit, if I let n go towards infinity and I have 1 over 2n plus 3 times 2n plus 2, I'm going to get what? I'm going to get 0. Okay, and it doesn't matter what x is out front, this limit is always going to be 0. Okay, so x has to represent a number. This limit is always, always, always going to be 0. All right, and if I think about what ratio test says, so long as this limit is less than 1. Okay, and because this is less than 1, for all x values, that's why the interval of convergence is going to be, it's going to converge for all x values. The interval of convergence is from negative infinity to infinity. Okay, so my interval of convergence is from negative infinity to infinity because this limit will be less than 1 for all values of x, and if my interval is infinitely long, then half that length, or from the center to one end, is also going to be infinity. Okay, so we just proved that that is an endless hug for that polynomial and that series that approximates it. Okay? All right, let's look at another one. Okay, so I have the sum of n factorial x to the n. I want to find the radius and the interval of convergence again for this one. Okay, so I'm going to have to ratio test it to do that, which means I need to find the limit as n approaches infinity, the absolute value of the ratio of two consecutive terms. Okay, so go ahead and try to set up your limit. Pause it and come back to me when you have your limit set up. Okay, remember that a sub n plus 1 is just exchanging all the n's with n plus 1's, and a sub n is just the general term that you're given. So I will have the limit as n approaches infinity of n plus 1 factorial x to the n plus 1 over n factorial x to the n, and I'm missing absolute value bars, so let me throw those in. Okay, and that's better. So I have the limit as n approaches infinity, absolute value of a sub n plus 1 over a sub n now. Okay, I want to simplify, which means combine my factorial terms, combine my x to the power terms. Okay, as far as our x to the powers go, you guys can do simple division with the x to the powers and then subtract exponents. If I do that, I have x to the n plus 1 divided by x to the n, which if I subtract my exponents, I would end up with just an x to the first. Okay, or you can rewrite the larger exponent as a product of the smaller exponent. Easier right now just to do the subtraction. Remember that the limit doesn't affect the x value, so I can pull that x to the first that I'm left with out, but I do need absolute values on it. So I can have, I can pull out that absolute value of x and have the absolute value of x times, and now I'm going to have the limit as n approaches infinity of, and I want to simplify those factorials. Okay, so I'd have absolute value of x times the limit as n approaches infinity of n plus 1 factorial. I could write as n plus 1 times n factorial. Divide by n factorial. My n factorials are going to divide out. Okay, and I am left with absolute value of x times the limit as n approaches infinity of n plus 1, and if I let n go towards infinity, I'm going to have infinity here. Okay, now if we think about the rules of ratio test, I need my limit to be less than 1 to be convergent, greater than 1 means I'm divergent, equals 1 means my test fails. Okay, right now I'm getting a limit of infinity pretty much no matter what x is, and if infinity is my answer, then that answer is always going to be greater than 1, with one exception. Okay, I want you to think about what that one exception is. What can I put in for x so that I don't get infinity? I get a value that's in fact less than 1. So pause it and come back to me. Okay, I want you guys to really think about that. So what can I put in for my x here so that when I take that number and I multiply it by a number that's getting infinitely larger, I'm not going to get something that's greater than 1. I actually get something less than 1. Well, if I put in 0 for x, okay, I'll have 0 times infinity. Okay, now I just want to take a second and just mention that I know that we said that 0 times infinity was an indeterminate form when we were doing limits, but that we were taking a limit that was... Okay, so the whole indeterminate form thing, sorry I got cut off, is that if you have a limit and you have a number approaching 0 times a number approaching infinity, it's indeterminate. But now if I'm taking literally letting x be 0 and doing 0 times infinity, I would get 0 as a product. So if x equals 0, then my limit is actually 0, and then I would get a value less than 1. Okay, so what I was saying to you guys in the first video at the very beginning is that every series must be convergent at its center, means it must be true at the center. There has to, that kiss has to happen. So this is a case where my interval only contains 1 point. Okay, and the way that I write that is I just put the one value that it's convergent at in curly brackets. Okay, and it's always going to be the center of the series. And if you just look up at the series again, it's just x to the nth power, which means it's centered at 0. And then it makes sense that it's, going to converge just at that value if it's only going to be one value. So I write it this way. Okay, and then if my interval only contains a single point, think about the number line, and if I only contain a single value of x, 0, how big is that interval? Well, it's not very big at all. It's got no length to it, so I say that the radius of convergence is also 0. Okay, so that's the interval convergence, that's the radius of convergence. That's for sure another option. Okay, let's look at another example. Okay, so here I have the sum of -1 to the n, x minus 4 to the n, over 5 to the n, and I've asked you to find the radius and the interval of convergence. I want you to look very carefully at this series and look at where all those n's are, okay, and think about what kind of series this really is, and pause it and come back to me. If you notice how n is only in the exponent of this series, that means that we have a geometric series. Okay, if this is a geometric series, I can very easily pick out, all I need to know is that absolute value of r has to be less than 1 in order for me to be convergent. Okay, so we're convergent if absolute value of r is less than 1. Okay, we need to figure out what r is. Okay, and the rule is that r is anything that is going to get the exponent. And if you're not really sure about what I mean by that or why that would make sense, try writing out some terms of the series and you'll very quickly see what r is. Because I have a -1 to the power, my terms are going to be alternately positive and negative, so there's going to be a negative that's part of my r. Okay, I have x minus 4 to a power, so my first term, I started at n equals 1 because I didn't indicate it, so my first term is going to have an x minus 4 to the first, the second term x minus 4 squared, the third term x minus 4 cubed, and so on, and then each term is going to be in the denominator. I'm going to have a 5 to the first, a 5 to the second, a 5 to the third, so all of those are components to my r. So absolute value of r would be absolute value of everything that gets an n as an exponent. So I need absolute value of r, which is -1, absolute value of -1 times x minus 4, divide by 5. I need the absolute value of that to be less than 1. If I take the absolute value of that, well, first of all, I'm not taking the absolute value of that because I have absolute value and I've got a -1 inside. I can just kind of disregard that -1. All right, it's not going to take any effect because of those absolute value bars. So I have absolute value of x minus 4 over 5 has to be less than 1. That means that for absolute value to be less than 1, I need my values to range between -1 and 1. So I would have that x minus 4 over 5 has to be between -1 and 1. Okay, and if I solve this, it's a simple solution. I I'd have that negative 5 is less than x minus 4 is less than positive 5, add the 4 all around, and I have that x has to be greater than negative 1 and less than 9, okay? Now, because this is a geometric series, this is only convergent if absolute value of r is less than 1. If absolute value of r equals 1, the geometric series is divergent, okay? Because if I have my r is 1, I'm doing like a plus 1, plus 1, plus 1, plus 1, plus 1 every time, and that would be divergent. Okay, and if r is negative 1, we'd have plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. That would also be divergent. So when you have a series that's geometric, you don't ever need to consider any more here. That is going to be your interval of convergence. Okay, so the interval of convergence goes from negative 1 to 9. Okay, so here's a real issue where we can actually figure out a radius of convergence here. Okay, if I'm going on an interval from negative 1 to positive 9, and here's another place where the center of the series takes a good role. Okay, where is the series centered? Think about it. It's centered at x equals 4. Okay, so I told you two things, that the radius of convergence is half the length of the total interval. If I'm going from negative 1 to 9, that length is 10 units. Okay, and half that length would be 5. Okay, or I told you that the radius of convergence is the distance from the center to one endpoint. And if I track from 4 to 9, it's 5 units, or from negative 1 to 4, it's 5 units. I can also see when I'm solving this that once I get rid of any coefficients that are multiplied or divided on the x, so right now I have an x over 5, once I get rid of that, divide by 5, I'll see my radius of convergence in the problem. So I got rid of that, I multiplied by 5, and I had these 5s here, the radius of convergence is going to be 5. Okay, as long as there's nothing that the x is being multiplied or divided by, you'll see the radius of convergence in your inequality. Okay, so there is my interval of convergence and my radius of convergence. Okay, and again, if it's a geometric series, you don't need to ratio test it because you know what r is, absolute value of r has to be less than 1, you're really good to go on this. Okay, and I said I would try to keep it to 2 videos, but I'm getting close to my 15-minute mark, so I'm going to just stop this one and start hopefully the last of 3 videos. Enjoy!